Hi, my name is Alusain Barry. Welcome to this lesson on the product rule for differentiation. This is part of a series on differentiation for calculus, further mathematics. Now, today we are going to solve one more example practice problem for the product rule for differentiation. Why don't we just find some space here? We're going to solve this Roman 3 problem here. Okay. What we see here, let's just rewrite our problem. We say we're given 3x squared in brackets x squared plus 4 all raised to the power 2. Okay, now as we discussed earlier, though it hasn't been stated that y equals to this function, we know that the function is defining some independent variable, okay, which we can say is y. So this implies that we have y equals 3x squared bracket open x squared plus 4 all raised to the power 2. Okay, now we can also say we can assume y to be made up of a product, right? Although there is no multiplication sign here, but the bracket tells us that this is a product. So this is why we are going to use the product rule. So we say let y be a function made up of two products u and v, which are themselves functions in x, okay, because they are going to represent these functions, where u is 3x squared and v equals x squared plus 4 all raised to the power 2, x squared plus 4 all raised to the power 2. Okay, now we have to note though, we say but according to the product rule for differentiation, dy dx of such functions, dy dx, the differential coefficient of functions that are a product of two other functions, which are themselves functions in a particular variable, in this case x. Remember, this can be 3z square, okay? So it doesn't have to be x. It's just because we are having x here. That's why we are saying dy dx. We should have said, if this was z and this z, we should have said dy dz, okay? Just so you realize. So dy dx is equal to v du dx. So we hold the second function constant and we multiply it by the derivative of the first one, u, okay, plus u, we hold the first function u here, and then we multiply it with the derivative of the second function v, so dv with respect to x, right? We are differentiating with respect to x. So now we can go on and say so now we have v, we know what v is, we know what u is, but we need du dx, we need dv dx, okay? So now we say du dx is equal to, now remember what we do is when we have a monomial such as this, we are going to multiply the expression to find its derivative. We multiply the expression by the power, which is 2 in this case, but then we will have to subtract 1 from that power, okay? So therefore we are going to get du dx as 2 times 3, which is 6, and then 6x raised to the power 2 minus 1 is just 1, and x raised to the power 2 is just 2 minus 1 is 1, and x raised to the power 1 is just 1, so we just have 6x here, okay? And dv dx is equal to. Now this is a composite function. Okay, we can imagine, let me use a color here. We can imagine this function being u, for example. So if this is u now, we can imagine v will be equal to u. Let's don't use u, let's say this is a. Okay, we are just representing with a name because we already have u here. So v is now going to be equal to a squared. Okay, so we are going to find the derivative of this, and then we are going to multiply it with the derivative of a itself. Okay, the inside function. This is what we do with the chain rule, remember? Okay, so what we do here, let's return back to our color. We are going to multiply the whole expression by 2. We say 2x squared plus 4 all raised to the power 2 minus 1 is just 1. Okay, but then we are going to multiply it by the chain rule by the derivative of the inner function. Okay, this one inside. So we will ignore 4 because the derivative of a constant is 0. Okay, derivative of a constant is 0. And for x squared, what we are going to do, we are going to multiply x. We are going to multiply the expression by 2 because 2 is the power, and then we subtract 1 from it. Okay, so this is going to be 2x, but x raised to x minus 2 minus 1 up here is just 1. So 1. So we just really have, this is going to be now 2, let's multiply out. 2 times 2x is going to be 4x multiplied by x squared plus 4. Okay, so now we can take more space and then find our derivative. Now we say hence dy dx is equal to, we have v du dx. V, what is v? V is x squared plus 4 all raised to the power 2. Okay, x squared plus 4 all raised to the power 2 multiplied by the derivative of u with respect to x, which is where du dx is 6x here. Okay, multiplied by 6x plus, remember the product rule, plus u, what is u? U is 3x squared. 3x squared multiplied by dv dx. Dv dx, what is dv dx? Dv dx here is 4x multiplied by x squared plus 4. So we say 4x multiplied by x squared plus 4. Okay, now we can simplify our derivative further. Of course, if we multiply, let's just make this easy by saying 6x into x squared plus 4 all raised to the power 2. Remember, a times b is equal to b times a. So we can also make this, can also, although rearranging it makes it look simple. Okay, plus, now we have 3x squared here multiplied by 4x. So we say 3 times 4 gives us 12. X times x squared is going to give us x cubed. Okay, multiplied by x squared plus 4. Right, so we have simplified our derivative. Right, ooh, this is we. La 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 la. Okay, now go on and find more problems to practice. This is it for the product rule for differentiation. Thank you.